Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And I'm Philip Sage.
Hey, Philip. One of the other contributors, Enrico Belamonte, has been writing articles for Ascendo for a couple of months now. And he recently posted a short piece of one of his articles up on LinkedIn, and it sparked all kinds of conversations. And I almost just skipped past it because it was the graphic that came with it was the bathtub curve, the classic hazard function with three zones, the early life failures or infant mortality. You know, I found that the medical device people don't like using the word infant mortality when they're doing a neonatal device. They just kind of frowned at that. So I said, oh, early life, let's call it that. So it had the early life segment, but it was labeled quality. And then the flat part, the mythical flat part, which I don't think really exists much for anything, he had labeled robustness. And then the increasing part on the back end of it was labeled reliability. And I'm like, So that caught my attention, and I read the article a little bit, and then the next day in my feed, because I liked the article, I got notified in LinkedIn that there was like 4 comments and all this other activity on that article and that short post. And so I went back to it, and somebody was going, what is this robustness thing? How do you do that? And part of the discussion was, well, we have a quality department to handle the issues that are related to the early life failure stuff. And we have a reliability department that's handling the end of life wear out and all other good stuff. But what's this robustness thing? What are you talking about? And then the whole discussion revolved around, to some extent, what are the definitions of the different terms and how do we deal with it? But I know I've seen this before, and it's one of those things where the puzzle of how do you deal with random events, that a random spike in voltage that's way beyond the expected or normal, or abuse, or all kinds of ways that we typically lump into that random failure mechanisms that occur to our products. But anyway, have you heard of that before, or seen this is broken down as the flat part is dealing with robustness issues?
No, I haven't. It's new to me. I'm going to have to do a search on LinkedIn and see if I can turn that article up. It'd be interesting to read the comments as well, and the base article, just to get a feel for robustness. You know, the bathtub, the flat part, often we I think misuse the word random failure, but it's really a period of very low failure rate on average is probably a better way to focus on it. And if that is robustness, where hopefully the product is working as intended during that part of its useful life, then I think that it's just another term. It's an interesting term that suggests perhaps a little bit more broader coverage of the terms, and maybe a little simpler explanation than all the technical terms that we've we are known to associate with that period of life.
Well, I'll track down that link and get it over to you. In short, is that, and I've seen this, and I don't always agree, but the early life failures are typically, not always, but typically associated with production or installation or shipping damage. And in many organizations, not all, some organizations then say, well, that's a quality issue. That needs to go to the quality department to get the process under control, or, redesign the packaging or do whatever, those kinds of things. And then the wear out section of the bathtub curve gets associated with the reliability folks, because we tend to deal with things that, not always, but we tend to do the accelerated life test. When will we have an increasing failure rate that will cause us problems? How will this last long enough? Will it extend past the warranty period? Will it survive 20 years? We tend to deal with questions like that, which is generally dealing with issues that are dealing with that wear out period and the back end of it. Now, the way Enrico approached robustness, and I've seen this other places too, is that if you create a product, any product, there's a whole lot of unknowns about exactly how it's going to be used and under what circumstances and what stresses. And then also there's an infinite number of unknowns of, well, how strong is that particular, and I'm using strong in a generic sense, how able is it to withstand the stresses it sees? And it varies from individual product item to the next item, from one component to the next component, and so on. And so robustness goes to the ideas that the product itself is resistant to just one more drop of your cell phone and the screen still doesn't break. If they design that cell phone such that the screen could withstand one drop but not two, well, that's not very robust, especially if you have a teenage daughter, which I did. Saw lots of screens break. In electronics, we know that there's dips and sags and spikes and all kinds of transients that occur on a power line. So if you design it so that it only works right at nominal, it's probably not going to work very long. So you add some margin. You add some, with the way Enrico and I've seen other places define it, is you add some robustness to it so that it can withstand a wider range of, or to account for this uncertainty of its ability to function and to what stresses it sees. So that's what I is a rough definition of what robustness is.
Yeah, I get that. It's kind of like your well, I guess your confidence limits, perhaps, or maybe that's the wrong way to describe it.
I wouldn't go that way. It's more like safety margin.
Yeah. Gives you a little bit of wiggle room,
right,
before you get into the failure. And the argument sounds like it's geared more for product single use rather than the asset management, where the term reliability, when we're working with repairable systems, we're designing the maintenance strategies that interact with that low period in the bottom of the bathtub to try and keep it there for 30 or 40 years, perhaps, for long life assets.
Right. Well, the pump, I have a recirculating pump in my hot water heater. It would fit in a coffee cup. It's not an industrial pump by any means, right? So one of the things they did is they said, well, we got to take care of water hammer. If these valves on your washing machine turn on and off real fast, you can hear it. It just bangs across the pipes. And he goes, well, we got to isolate it from some of that, dampen that hammer as it comes along. So they put another device in the system to take care of that. And he did a couple other things to basically protect this small little fragile pump from the harshness of its reality in our house. Whereas an industrial pump is 600 pounds and, it's got margin built into it because the expectation is it's going to do a pretty hard service load for 40 years.
Yeah, the same thing is true in my career. I worked in the steel business for 15 years, and the electrical motors there were mill duty MD frames, and they were meant to be electrical machines that you installed in overhead cranes and in other places that were very hard to get to. So you really, really, really counted on those machines having that extra margin of robustness to be able to run and survive for a very, very long time, and to endure even semi-intentional overloads at time and still be able to stand up and continue working as needed.
Right. And I think you get it. That's what we mean by robustness. Now, the conversation in that thread quickly turned into well, we don't know, nor can we afford to know. And I dispute that to some extent, how a customer is actually going to use and abuse our product. And I'm like, well, that sounds like you're giving up on it. And the other one that really irked me was like, well, we can't replicate our customer's use profile in a lab. So we design for what we can do in the lab. And he says, well, reality doesn't care what you have in the lab or not in the lab. Your product is going to work outside the lab. It's got to be designed to work there. And one way to do that is to build in margin on it. Use component derating or stress strength calculations or safety margins, those kinds of techniques. And there's others also. And then of course the comment was, well, then it'll be grossly over-designed for vast majority of people. And it says, well, if your flat part of the bathtub curve is too high of a failure rate, that's a way to go about doing it, is make it more robust, make it able to withstand things that it should survive in order to work in that environment. And it really got down to, there's a whole lot of techniques to make something more robust. And I mentioned just a couple of them, but it's a balance. Is, well, how well do you understand the use conditions and the environmental conditions, and how well do you understand your material set and your product itself and what's it supposed to do and its expectations? And all of that takes money. Whereas if you just make it twice as heavy, for example, add cast iron instead of tin, you might not be able to sell it. So, not a lot of homes have a overhead crane to install the pump. It's just not something we have laying around here.
Whether there's all those design compromises where you have to size and weight and complexity, robustness is an important one that we're talking about, and trying to find the sweet spot in all of those different areas. And to replicate the real world from a laboratory is very difficult, because the laboratory often doesn't match the real world in every aspect. There are standardized tests for vibration and humidity and temperature and so forth, environmental conditions, but you really can't replicate everything. And your topic of the cell phone, I just talking to a colleague the other day who had his cell phone in his shirt pocket and leaned over to pick up something in the toilet, and the cell phone slid out of the pocket and went right in and slam dunked, where, and that was the end of the cell phone. It wasn't made to be submerged in water.
Yep.
Fortunately, as he tells the story, it was clean water, but nonetheless, the moisture got it, and it was done. Yep. So I there are certain things that you have to be able to design for, and you're hopefully designing your product to be just a little bit better than the other guy's product so that you get the sale. That's the whole idea of offering a product, is to convert it and to make money. And that means that you have to have at least the same robustness as your competitor. And if you don't, you probably need to add some robustness so that during the expected useful life under an expected hypothetical set of conditions, that the product functions well and has a very low failure rate. And only when it reaches the end of its useful life does we get into that increased hazard rate that we're terming as the reliability zone, perhaps.
Yeah. One of the issues I have, and I've run into this with a number of clients, is there's two pieces to this. One is, well, what's the expected user use profile? Well, how many times are they going to use this a day? In some, how many times am I going to push the on-off button, for example, on something? And when I was at Hewlett-Packard, the marketing department spent an enormous amount of time and money trying to answer those questions. And they had categorized the customers for one particular product line I worked on into 5 different groups, from the, somebody prints black and white once in a while to somebody prints full page color every day and a lot. So think of a real estate agent that's printing brochures to sell a house. Every time they get ready to sell, they're printing off more of these brochure things or these flyers. And each one of those had different expectations of how the product would work and its quality and all this other stuff. So they documented all kinds of stuff and handed it off to the design team. So we had a trove of really insightful information. Then they looked at it and said, well, what's the temperature inside these different locations and types of customers and stuff? And so another team spent years instrumenting systems and getting them into all these different typical environments and actually measuring it. And they found temperature was actually pretty close to what the outdoor temperatures were in that region. It was offset by just a degree or two. But humidity was very different. And a handful of other things were very different than what the outdoor weather stations would report. And so we didn't really know until we measured it. And the other one you mentioned is like transportation, the standard test for that. We had a guy that instrumented packages and would send them all over the country to ourselves, basically, and instrument how UPS treated a product versus FedEx versus air travel versus boat travel, whatever. And the standards didn't even come close to the magnitude and strength of some of the shocks and bumps and things these packages got and the environments they went through. It wasn't even close. So I really hesitate to use a standardized, vibration test because it's a very low bar compared to what reality is. I know that from experience. Now, one other thought I had is thinking back to our last episode on vintage experience. I don't know how many in our listening audience would remember the ads from Samsonite luggage and Timex and Timex. Timex was, takes a licking and keeps on ticking kind of thing. You remember the Samsung commercials, Philip?
You used to drop them out of an airplane or something, didn't you?
Yeah, they dropped one in a gorilla's cage at a zoo, and the gorilla played with it for a while, and it would just, the latches still work, the hinges still worked. It was, they should have left it at the airport on the tarmac and let the baggage handlers take care of it. Not that that's a slight on them at all. They got a job to do.
Going to jinx all of our air travels. Be careful.
Yeah, that's right. That's right. But the idea of robustness, and it goes back to a story, and I probably told you this story before, is that thinking of the baggage handlers, is they were making one of the early barcode readers. It became necessary for aircraft crews to scan. If a person checks a bag but doesn't get on the plane, they'd have to unload it and take that bag off, and I think there was a handful of incidents where somebody planted a bomb that way. So there was a reason for doing that. So they thought, well, we got to streamline this. This is pain. So they barcoded our luggage bag or bags. When you checked your bag, they'd put a barcode on it and scan it in. And then if you didn't get on the plane, they'd be alerted to that. But they would also check to see if it actually got on the plane. So if you looked out the window when they're loading the bags, you'll see them scan every bag going on and coming off. It's a part of the process for them to efficiently lose your luggage just when you need it. But one of the things they learn very, very quickly is that they treat these little barcode readers, these battery-powered little readers, about like luggage. They drop it, they throw it around, it falls on the tarmac, which is concrete, or covered in ice sometimes, but it's usually a hard surface. And and they were perplexed as well. We did the standard test and it said to drop it 10 times from 3 meters or from 3 feet, 1 meter onto a hard surface. And they passed that test, no problem, but they didn't last a day out at the airport. And to make a long story short, they're up to, I think it was 15 feet and 100 drops that they had to survive. And then they were able to survive well past the warranty period.
Wow. Well, it is a challenge, and especially when you're dealing with product quality, it's a slightly different game than asset management, where you're repairing an asset and keep on going. But it's interesting. I think robustness still applies in both cases, and that the quality aspects, whether it's early life or infant mortality, which is where it got its name from the mortality curves of different countries and the high likelihood that in the early years as an infant that you would pass away in those countries is where that term, of course, comes from. But yeah, I think today they're largely quality problems, or in the way that the things are made. Certainly, in the 60s and 70s, electronics were kind of in their infancy, not where they are today. And that was the era where we still had a lot of vacuum tubes being used. So getting a tube that worked meant that you had one that was good for a long period of time, but not always did they work, and you had to change them out.
Yep.
So I think, that part of the curve is pretty well documented and understood. The end of life and when a product is going to need to be replaced, or you have to go to the store and buy another version of it, is all about robustness, and having too much robustness can be not a good thing, because especially if it increases the size or the weight or alters the appearance or any of the above performance or aesthetic factors. Those all have to be balanced to a point where you think you got it right, and then you have to look at the response in the market for that particular model of the product, and then use that information in your next design to improve.
Yep. Now, well summarized there. It was interesting to me that it sparked such a conversation, and eventually it looked like it was winding around that very much what you were just talking about. Yes, it's an investment to understand how your product's going to be used and where and how long what the expectations are. Yet without it, you're pretty blind, and you can very inadvertently create something that just won't work. And it's hard to recover from a start like that. So the robustness isn't here's just one tool or one metric or whatever. It's in relation to what's your customer's expectations and a bunch of other factors that you just mentioned. So it was an interesting idea. I'll see if I can track down that link and get it over to you, and we can add it to the notes. That'd be cool. But it's something that's worth considering and talking about. If you're designing a product or in the asset management world, maintaining stuff, how does something that is accepting overload, not continuously, but on occasion, for example, or one extra drop, is the cell phone's history in my household is well familiar with. Let us know. Head over to accendoreliability.com/go/SOR. There's a couple of ways you can get in touch with us there. Philip and I and the other hosts of the show are available through LinkedIn and through our About pages. So there's lots of questions that come in every now and then, and we get to respond to you, and many of those end up being fodder for an upcoming episode. So, join the conversation. Let us know what's on your mind, or if you have any thoughts about this particular topic, we'd love to hear from you. So I guess with that, Philip, I think we'll head off to the rest of the day and see how many things we can break, see how robust they are.
All right. Thanks again, Fred.
We'll talk to you later, Philip.
Bye now.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.